So today we're working on interiors and exteriors. So on here, if you look at where it says tangent and secant, so I know we've heard tangent before when we were doing trigonometry. That is not what this is talking about. So we have tangent lines to a circle. So just for future reference, if you see that in a word problem, a tangent line is going to touch the circle once. It's going to always be completely outside the circle. And it touches only once. So a tangent line is like XY right here. So it's completely outside the circle and it only touches in one spot of the circle. So it's the only place it touches that circle. And then the other vocab word I got for you is a secant line. So secant, and we're not. So a secant line is going to be inside and outside of the circle. So it's going to be both. Okay, so in and out of the circle. Touching twice. So the other one, this one right here, touches right there. And this is the part that's inside the circle, and then it touches again there, and these parts are outside of the circle. So a secant will touch twice like that. So it'll kind of go through, if you want to say it just is drawn through a circle. So that's how that is going to look. Okay, these are just to help us in the future if it says there are secant lines and things like that. Plus, I'm going to be using the vocabulary. So this is how two secants will look. These are two lines drawn through the circle. That's basically all a secant is. It's drawn through the circle, so it touches twice. So these are the types of angles we're going to talk about today. We're going to have a couple that are on the exterior as well, so you'll see them on the outside, and I'll show you those when we get to them. But we're going to have two secant lines crossing, so it's going to make angles in here. These are not central angles because they are not through the center. Okay, so they're going to be a little different. They're also not inscribed angles like we did yesterday because the vertices, the vertex, is not on the circle. So these are a little different. So these are your two main formulas for the day. Up here, these are the inside angles. So when you have two lines crossing and you have angles on the inside, what you want to do is you want to add, if I'm looking for this angle here, you want to add up the arcs and then you want to cut it in half. So if I'm looking for this angle here, I would add up that arc and cut it in half. So you basically are adding the arcs that the two lines, the two crossing lines make, that the angle makes. So you want, because both of these angles are going to be equal to each other. So you want to take the arcs that those two angles make, add them up, cut them in half. When you're down here, these are what the angles on the outside are going to look like. So this is two secant lines right here. So we have two secant lines because they're drawn through the circle. Over here, you've got one secant and one tangent. It's not really a big deal that it has that. It's just showing you three different ways the picture will look. And this is if you have two tangent lines. So either of the three ways, all three angles are outside of the circle. And if they're outside like that, what you have to do is you have to take the bigger arc right here and subtract the smaller arc. That way you don't get a negative. So we're talking about the arcs, the two arcs in the circle that this angle makes. It makes two different arcs. So you want to subtract them, cut them in half. Okay, so that's all three of these will look that way. And we'll draw those on our circle sheet when we get there for a little formula sheet. So that's it. Those two formulas, that's all we're dealing with. So here are the rest of the notes are just an example. So if you notice that angle 1 is inside. So what you're supposed to do is you're supposed to take the two arcs that angle makes. So this angle makes this arc here. The same angle on this side makes that arc there. So you just take them and you add them and you cut them in half. That's all you got to do. So I got 92 divided by 2, which is 46 degrees. Okay, over here I'm looking for angle 2. And this one, if you notice, this is an inscribed. So we're not, if we'd use this formula, you'd be doing 92 and 0 because there's no angle there. So you'd be doing 92 and 0 and cutting in half. Or if you notice, it's just inscribed. The corner is on, the vertex, is on the circle. So this is where we just took 92 and cut it in half. So that's kind of from yesterday. And that's going to be 46 degrees as well. Same thing here if it's inscribed. So these are kind of older problems. If it's inscribed like that, you can just cut this in half. So I threw those in there so you can see the difference between, let me scoot up a little. So you can see the difference between these ones these ones, and these ones. So if it's inscribed, it's the corner is on there. Outside, the corner is literally outside the circle. And if we're talking angles on the inside, you're basically going to have an X. So it's two lines crossing through. So in this case, I've got 110 for angle 3. Okay, now these are all ones that apply to those formulas I told you about. This is on the inside, so this is not a central angle. So you have to use the two arcs that the angle makes, this angle and this angle. So I've got the 90 and the 46. Add them up, cut them in half. So that's going to give me 136. And half of 136 is 68. Yes, so 68 degrees for X. Okay, over here, this is an angle on the outside. So we're looking at the two arcs that it makes. It makes these two. So you want to take the bigger arc minus the smaller arc, cut it in half, and that's going to give you your angle. So in this case, you have to actually solve for Z. So get rid of that 2. You're going to times by 2. And then we're going to subtract the 95 and divide by -1. So Z is 55 degrees. Okay, so sometimes they don't give you those two measurements. Same thing over here. Sometimes X is out here on one of those arcs instead of the angle. Okay, so a bunch more down here so we can see what it looks like. So this is on the outside. So if you have an outside angle, you're supposed to take the big arc minus the small arc, divided by 2, and that's going to give me my outside angle, which they gave me as well. So similar to the last one, I got to times by 2. Okay, and then I'm going to add the 100. So arc W is 240 degrees. Over here, this is one that's just going to be a normal setup. So I'm going to take the big arc minus the small arc, cut it in half, and that's going to give me my angle. So this is going to give me 80. So if I do 80 divided by 2, that's going to give me 40 degrees. All right, up here, these are inside. So these are inside, but they are not central angles. So you want to take the two arcs that the angles make, that those vertical angles make, and you are going to add them and then divide by 2. So if they're outside, you subtract. If they're inside, you're going to add them and cut them in half. And that's going to give you my angle. So in this case, times by 2 and subtract the 30. Now, if they happen to ask you for this arc, so if they ask you for the ones that don't belong, right here is 35 to make a straight line, so that's 180. So if I subtract, that's going to give me 145 right here. So in that case, if I'm looking for it, I've got the 145. So you just have to, if they just ask you for the angle, I mean, you just have to subtract from 180. So sometimes they make you find this angle, and then you'll have to subtract from 180 to get that angle. So you'll see those. I think I've got one of those as well. All right, so for this one, for angle 3, I have 2 things missing. All I have is the big arc. So I got 220 minus, I don't know. So you do have to keep in mind if you get a double tangent right here, it only makes 2 arcs. Remember, a full circle is 360. So you're going to subtract the 220 from that, and that's going to give you 140. So this is 140. So if I do that, that's going to give me 80 divided by 2 is 40 degrees for the measure of angle 3. Okay, and then I had 2 more down here. I didn't have one like I was saying up there, but you will see those. So in 5, I'm looking for X. So again, in that case, if you have a double tangent, that is possible to do this. Now, I put this one on here because it's super tricky. Because I have a missing right here, and I have another unknown right here. So keeping in mind that the whole thing is 360, if I did 360 minus whatever X is, that is going to give me the big arc right here, which I drew terribly. Anyway, so we're going to solve it the same way. You're going to have the 360 minus X, and then minus this X divided by 2 is equal to your angle. Okay, so I'm going to put those negative X's together, get negative 2X, times by 2 to get 100, subtract the 360, and divide by negative 2. So I'm going to get 130 degrees for x. Okay, if they asked you for the big arc out here, you'd have to do 360 minus 130. And then that would give you your 260 or whatever, 230. All right, last one over here. I've got two secant lines. They're drawn right through it. So I've got my 100, and I've got something missing there. Divide it by 2, and that's going to give me my x. So to get that part that's missing, notice they had to give us other things in this problem. So you'd have to do the 360, get rid of the 110, the 100, and the 80 to get this remaining piece right here. So minus 110, minus 100, minus 80. So that's minus 290, which is 50. Oh, 70, sorry. Right? 290. Yes, so 70 for that red part. So sometimes you have to do a little figuring to find those arcs. So this 100 minus 70 is going to give me 30 divided by 2. Gives me my 15 degrees. Okay, so the last thing I want to show you is to add on to, oh, by the way, if you want, I just threw a couple of extra problems in there just in case. This is the one that I was talking about in the other one. So usually we would find these angles. So you can take the 150 and the 110 and add them. I knew I put one on here somewhere. Divided by 2, and that's going to give me, we'll call this x. So this is 260 divided by 2, which is 130. So that's here, the angle they're asking you for. What you have to do is you have to take 180, because they both make a straight line. You just have to take 180 and minus 130, and that's how they got the angle right there. It's 50 degrees. Okay, so sometimes they ask you for a different one in there. Solve for one of these, subtract from 180. All right, so I gave you, and of course you can come back here and pause and check them out. The starred ones are a little bit more difficult, but just in case you wanted some extra practice, they've got the answers in pink so that you can check those out. I'm not sure I'd worry too much about that one right there. Okay, but some of the rest of them with the stars, like this one, that's not too bad. I don't know why it's starred. It's not that difficult. This one I wouldn't worry too much about all the x squareds, but you can, when you minus, they're going to go away anyway. So it'll make it a little easier. But those are extras, so you can go through and pause if you need to. But I wanted to add the last couple of things on here. So the things that we're adding new, I think we're going to finish a side, actually. So the ones we're going to add are on the angle side. So find your angle side, and we're going to finish those two on this one. So what I want to add is the inside angles. So in this case, you want to have some kind of X in there, but just don't make it go through the center like I just did. So these are angles inside, but not in the center. So if you're looking for like angle 1 right here, and we can label them A, I think I labeled it differently when I did it yesterday. So I did it on, no, I made that one A, hold on. Just so it'll match when I do the notes the next time. I did this as A, B, C, and D. Okay, so when you're looking for the angles on the inside, then what you want to do to get the measure of angle 1 is you want to add up arc AB and arc CD. And you want to divide them by 2. Okay, so that's how that one is going to look. And then the other one over here with this little sideways stop sign, these are going to be angles on the outside. So these ones I put over here, I did angles outside. So these are when the angles are on the outside. So you can have one something like this, where you have a double secant. So that's going to be on the outside. I made mine really little, so I don't want to put an X in there. It's hard to see. Okay, so if you're looking for that, this is going to be 2 secants. And then you can also have, when you have one tangent and one secant, so I did another one that looked like this. That's my tangent, it only touches once, and my secant. Okay, and then finally, I guess I should write that. One tangent, one secant. And then finally, I did one with 2 tangents. So 2 tangents where it only touches once here and here. So I've got 2 tangents for that one. So it's just 3 different ways that the outside angles can look. And then for your formula for that, when we did our formula, the measure of angle X is equal to the big arc. And the big arc is, I mean, obviously there are 2 arcs in all of these, 2 arcs made by each angle. So you want to do the big arc minus the small arc. And we're going to divide that by 2. So we're finished with that side. And that's all the stuff that's going to be on your quiz. And then we'll continue with the rest of that stuff on Monday. Okay, so after today's stuff, we'll do a review tomorrow, quiz on Friday. Good luck.